Ah, okay.
Upon returning the penguin, they can get
So sorry, penguin is taped up on.
yeah,
That's funny. Okay. Afternoon, everyone. Audio's okay? Never know how this is going to go. Thanks for joining me for this funny session, to be honest with you, spanning tree. My name is Patrick Gargano. I work with learning and certifications. I'm a content developer. I'm an instructor from Canada. Actually, I'm French Canadian. I come from Quebec. And so traditionally what I like to do during my session is to give out something that we make in Canada, which is quite popular around the world, which is maple syrup. But obviously I can't give you a can of maple syrup. It would, they wouldn't let me they wouldn't let me leave the country with all that maple syrup. So what I do is I bring maple syrup hard candy. So trying to make this a bit interactive this afternoon. So if I ask you a question, you get the answer, you get a candy. Try not to answer all the questions and get all the candy. I just brought a kilo of it, so I'm hoping that it's going to last me all week. For the past couple of months, Hank Preston and I have been doing these CCNA prep sessions on the Cisco Learning Network, live streams. We've done trunking and VLANs and Ether channel and routing, static routing, dynamic routing, and we did one. And it was quite short. It was about an hour long. And I thought it'd be nice to kind of build on that one and go through an actual spanning tree scenario. Because for CCNA prep, for those of you that are thinking or working on getting your CCNA, you need to understand not how to configure spanning tree necessarily, but just how it actually operates. Like if you plug in a bunch of switches and stand back and wait a few seconds, what happens, right? What's actually happening on those switches for this to actually work? So that's what we're going to go through. Now, obviously, if we're talking about spanning tree, we're talking about going back to the 80s. So I thought we'd break the ice a little bit and talk about some kind of cool things that happened in the 80s. So first of all, you had the mullet. This is a proper Aussie mullet. So here we go. The first candy prize is which footy team does this player play on? Yes? Cindy Swans, there we go. For 2 pieces of candy. Anyone know who this player is? Hang on, yeah. Very good. 2 pieces of candy here for this one. So yes, look how lush that is. Like that mullet is a proper mullet. Proper Aussie films from the 80s as well. This is an easy one. Now for the candy, what I'd like is the full title of this film. Anyone want to have a go here? Yeah? Yes? Would there be 1, 2, or 3? You know what? I'm going to give it to you anyways. So Mad Max 2 would have been this film. Good film. Now, I want to try something a little different for the music. Obviously, lots of excellent Aussie rock bands in the 80s made their way all the way to Canada. So I tried something here. I created a playlist, and I'm going to try to run it from my phone. Hopefully, you're going to hear it in your headphones. I'm only going to play a second or 2 of these songs. There's like 5 or 6 of them. If you get the song, what I'd like to know is the song name and the artist. Quickly raise your hand. I'm going to stop it, and we'll see if you get the right answer. So are we ready for this one? Okay, here we go. Anyone? Did you hear something? You didn't hear anything. Did you hear it now? You already have candy. Anyone else not have candy would like to try? Anyone? No one? Did you hear the yes? Thank you very much. These are not trick questions, guys. Like it's very basic stuff. Next song. Anyone? Yes. Midnight Oil is correct, but I went with a deeper cut. Anyone have the full name? No? The Dead Heart was the name of the song, but it was the band for sure. How about this one? This is an easy one. Okay, so you know it clearly. What is it? Thank you very much. Next one. Shirley. Yes. Thank you very much. Last one here. Oh, no, actually, 2 more. Yes. What was that? Good. Very good, guys. Very good. Okay, last one. This is a bit of a deeper one, a deep cut here. No one guessed this one. It's oh. Very good. Look at you guys. You guys rock. Okay, really, really the last one. We need to start talking about spanning tree. This is an excellent song. Nice mellow one here. No one? Going once? Going twice? No, okay. Under the Milky Way. Sorry? What was it? Yes, the church. Let's see if you reach that. Nice one. Okay, all right. So that's enough of that. We're in the 80s. We need to talk about the LANs in the 80s. So listen, we're talking about different types of media. It could have been coax. It could have been, and if it was coax, you might have had then repeaters, right? Extending those LAN links, creating these very long and problematic collision domains. If it was Cat 3 or 4 or 5, you would have had maybe hubs. Again, you would have connected a few of these together, collision light flashing like mad on the hubs. And creating these big collision domains. At some point, someone clever thought we need to stop just having these layer 1 devices. We need to have something similar, but that's a little bit more intelligent, a bit of layer 2 intelligence, looking at the MAC address, source MAC, destination MAC address. And so we would come up with these things called a bridge, which would break up these collision domains, right, to be a little bit more intelligent. And same thing with the switch. A switch is just a multi-port bridge. It's just learning MAC addresses and making smarter decisions about where traffic has to go. At the end of the day, though, someone a bit funny decided that they would plug a bunch of these in all together and create a loop for redundancy, which seemed like a good idea at the time. Unfortunately, the network would then crash, had no idea what was going on. They had no concept of the TTL. They didn't understand that the frames were just traveling around and around this layer 2 loop. So they reached out to a very clever, amazing lady in the early 80s. Anyone know what her name is? For Candy again. What's her name? What's her name? She's the inventor, the creator of spanning tree. No? Radia Perlman. She comes up with a very elegant, very simple solution to the problem, calls it spanning tree. We're talking about 1984 at this point. So this is what I'm looking at for the next few minutes. I'm just looking at traditional legacy spanning tree, not rapid, not multiple spanning tree, just the traditional one. And again, what is her solution? Her solution is this, right there. She wants you to have your layer 1 redundancy, but we need to break that bridging loop at layer 2. So how does she pull this off? Pretty straightforward, and we're going to use these steps over the next few slides to kind of break through or break down an example of spanning tree, if you like. The first step that she comes up with is we need to allow these switches to talk to each other and select the boss. Select the heart of the layer 2 network, and she's going to call that the root bridge. And notice the use of my verb here, elect. There's going to be an election process. All the switches are going to be like, no, it's me, and then one's going to get chosen. Step 2, all the other switches in the network have to figure out what is the fastest way for them to get to that root bridge device. The fastest, best loop-free path there. We're going to call that a root port. And there's a classic CCNA exam question, which goes something like this. How many root ports are there on the root bridge? And what's the answer? The answer is none, because the root ports are found on all the other switches, not on the root bridge, right? They're pointing towards the root bridge. That's why it's called the root port. And then finally, step 3 is all about selecting what we call the designated port. Now, this is simply, listen, there has to be one on every network segment. When I talk about a network segment for the next 20 minutes, I'm talking about a layer 2 segment. So on this diagram, we have 3 segments. I have to have a designated port on each of those. So in step 3, we're going to find out which one that is. Which one is the designated port? And then whoever is not a designated port, this happens to it. That's where things get blocked, right? We're going to call that sometimes also the alternate port on a Cisco switch. At the end of the day, I want this to happen somewhere. Is this all making sense? Okay. How's this all happening? We've got this nice little simple messaging system within Spanning Tree that uses something called the BPDU, Bridge Protocol Data Unit. This is a little message that gets sent out every 2 seconds by the root bridge. It's literally like a heartbeat. Boom, it goes out throughout the whole layer 2 network. Boom, another 2 seconds. Now, there's loads of stuff in the BPDU. I want to focus on 4 really important fields, and we're going to use those over the next 15 minutes to kind of work through a spanning tree example. These 4 right here. First one, the BPDU is going to carry who the root bridge is, right? What the ID, who is it? That's the heart of the network. And how much does it cost this particular switch that just sent out this BPDU? How much does it cost it to get to the boss? And then who is the switch that just transmitted this BPDU and out of what port, right? So that's pretty straightforward. Who the boss is, how much it costs me to get to the boss, who am I, and what port did I use to send out this BPDU? I'm going to use those four over the next few slides. Let's talk about this very, very quickly. And again, we don't have loads of time here. So I'm hoping you're already familiar with spanning tree, and this is just kind of refreshing your memory. If not, you need to do that deep dive within spanning tree. The bridge ID is a couple of things, two values together. The MAC address, the base MAC address of the switch, and something called the bridge priority. Now, this is a 16-bit value. So in theory, it could have any value between 0 and almost 65,000. Radia decided, what value is the default? Going to go right down the middle. 32,768 is going to be the default value for the bridge priority. And then we're going to add the MAC address, and that's going to give us our bridge ID. Obviously, on Cisco switches, we do clever stuff like per VLAN spanning tree. And so when that starts happening, we need to kind of borrow some bits to be able to track the VLAN ID. But put that aside. We're just going to pretend for today it's one VLAN, VLAN 1, and that's the whole the spanning tree for that VLAN. One more little review slide before we jump into the example. Now, every time a decision has to be made, who's going to be the boss? What's going to be the root port? How about which one is going to be the anytime we have to make a decision, we're going to use this 5-step sequence here to make the call, to get a winner basically out of that election process. We can't have a tie. We need tie breaks and we need a winner. So hopefully you've noticed already a very key element. Again, Radia decided in 1984, should I go with low values or high values? I'm going to go with low values. So anytime I ask you, or you're looking at spanning tree and you're wondering which one's going to win in this particular case, it's always going to be the lowest value that's going to win. So the lowest bridge ID, lowest root path cost, lowest sender bridge ID. You get the idea, right? All the way down. The last piece of information that we need, just so that the example makes sense over the next few slides, is let's talk about cost. So what is the cost? It's not complicated. The cost is a value assigned to the speed of the link, right? The speed of the interface, if you like, on the switch. These are like the traditional values, what you would have seen over the last 10, 15, 20 years, 19 for 100 meg and 4 for gig. Obviously on our LANs today, our links are super fast, like massively faster than that. So these values don't really make much sense anymore. You can use a command to switch to a much longer value so that you can then tweak your cost values. Why is this so important? Well, I was talking about the second step here, right? We need to figure out what the root path cost is. And what's nice is it's really simple. It's just a cumulative value of all of the links that I have to go through to get to the boss. That's all. And I'm just going to add those values up and I'm going to find out what the root path cost is. That's it for my review. Take a breath. And this is the topology we're going to work through. All right. So I like that. Lean in a little bit and figure out what's going on. Got 5 switches. 1, 2, 3, 4, 5. A quick look at the diagram, you'll see that there's some fast Ethernet links and a bunch of gig links as well. I put the priority values to the default value just to be nice. So you don't have to like start scrutinizing the priority value. It's all the same, 32,768, but the MAC addresses are different, which makes sense. So kind of take that in, and here we go. Step number 1. If you remember what step number 1 was with our spanning tree process, we need to figure out who the boss is. Which one's going to be the heart of the network? This is the one with the lowest bridge ID. I'm reminding you what that is. Combination of the priority and the MAC address. Raise your hand if you think switch 1 should be the root bridge. Switch 2, 3, 4, okay, and 5. And the winner is switch 5. So what's going on here? We always look at this from left to right. So we look at the priority first, 32,768, 32,768. They're all 32,768. Then we look at the MAC address, again, left to right. So 0009, I got a B here. I've got an F, I've got a B, I've got a B. So 9, these are hex values, obviously, is the lowest value. This guy is the root bridge. Is everyone okay with that? This would have happened if I turned off these switches and turned them on, this happens within a few seconds, right? This is the first step of spanning tree that it needs to figure out who the boss is going to be. Cool, that was easy. That was step number one, we're done. Now, remember what I said earlier about the BPDU? Now that switch is going to start sending out that heartbeat every 2 seconds, boom, the BPDUs go out. And it's going to send a really interesting BPDU. Do you remember there were 4 fields, right? Who the boss is, how much it costs to get to the boss, who am I, and what was the port. So in this case, what does it look like, that BPDU? It's basically saying, I'm the boss. It costs 0 to get back to me because I am the boss. And I am sending this BPDU, and I'm sending it out of these different ports, right? So that's what that looks like. And these are coming into the neighbor switches on fast Ethernet interfaces, could be on gig interfaces. And so these guys start adding these cost values together, the value that it arrived with, which was 0, and then it adds a value of the port itself here, right? So now it knows, this guy knows that it costs 19 to get to the root bridge here. It knows over here, 19 or even 19, right? There's parallel links. This one as well, 19 down here. Now, I don't want to show all the BPDUs flooding throughout the entire network, but basically at the end of the day, what we end up getting is a quick calculation across all these paths of which one is the best path. And don't forget, the best one will be the one with the lowest root path cost. So I'll just point out a few, just for example. If I go out of this port to get down here, it'll be a gig port, so that's 4. And then either down that one or down that one, which is 19. So 23 plus, there we go. So we got 23 is a total out of this port. Check out this one here. Why is this one 27? It's kind of like going maybe around this way, right? So 4 plus 19. So what these calculations that you're seeing are just simply me kind of adding what the cost value is. I'm going to use the word hop. I know it's not a hop, but you get the idea, through every switch as we go there. Why is this one 38 out of this port? Well, it's 19 because it's a fast Ethernet port, and another 19 coming this way. So 19 plus 19 is 38. So this happens throughout the whole environment, and we know that I need to figure out the best one, right? The one with the lowest. So what I tried to do, I just cleaned up the diagram a little bit, got rid of all the math, and just gave you the final values, if you like. So in other words, if this switch is coming out of this port, it has a root path cost of 23, right? Coming down this way. So let's have a look here. So let's start on that switch. Lots of options. Which one should be the root port out of that particular switch? And we're going to use the lowest root path cost. Is it 27, 38, 23, or 19? I think hopefully it's obvious the 19 is the lowest value. The 19 wins. And so this one becomes the root port for that switch. I'm not doing it in any particular order. I'm just doing them randomly here. Oh, sorry. I gave you the answer. Don't look. What's going on? Wrong button. Okay, this guy over here, 19, 23, 23. 19 is going to get chosen. Root port over here. If we go up to this one, it gets interesting now. What I mean by interesting is that we have a tie. We need a tie break. And the tie break always happens thanks to these 5 steps. And basically what we had is we had a tie on number 2, right? Both ports have a value of 23 to get to the root bridge. So we need a tie break. We need to go to the next step. And we need to look at the lowest sender bridge ID. This is going to be the bridge ID of the neighbor switches. And if we have a quick look at these two, 32.768, 32.768, which one is going to win this particular tie break? Switch 2 or switch 3? Is it, raise your hand, switch 2? Thank you. This one has the lowest sender bid. If you have a look again, 000B, FD13, 9. 9 is lower than C. That one won. And so this is the root port. Are you ready for the tricky one now? This is the one you'll get on the CCNA exam. They're going to show you a switch with parallel links to another switch. In this case, I made the switch links to the root bridge. And they're going to ask you the question I'm asking you. Which one is going to be the root port? I'll just let you think about it for a second here. Again, why is it complicated? It's because we have a tie for step number 2, right? Both of these ports have a value of 19. And then we have a tie for step 3 because these BPDUs are coming from the same switch. So we go to step 4. Now you're gonna ask me, Patrick, port priority, that's just a value that you can manually configure on a Cisco switch. The default value is 128. So let's leave it to that and go to the final ultimate tie break. And the ultimate tie break, ladies and gentlemen, lowest sender port ID. So who thinks that on switch 2, FA01 should be the root port? Raise your hand. Who thinks it should be FA02? Don't look here. You look at the sender port. The sender port. Hopefully, is this making sense? This is the port that is sending the BPDU to the neighbor, right? I can guarantee you a question like this on the CCNA exam. So that's the root port. Are we doing okay so far? Cool. All right, we're good. Step 3 is going to be the longest step, folks, because there's a lot of segments in my topology. And if you remember what I said earlier, when I'm talking about a segment here, I'm just talking about that's a segment, that's a segment, that's a segment, that's it, right? Every one of these at a layer 2 perspective is a segment. I need to elect a designated port for each one of these. Doesn't matter where I start. I can start anywhere. How are we going to figure this one out? We're going to use the root path cost as the starting point for that conversation. And what happens is it's like a fight. It's an election process on the segment. So imagine I have a segment, I have a switch and another switch, and they're kind of fighting it out to figure out who's going to be the designated port on that segment. And who's going to be the winner? It's the one with the lowest root path cost, right? Here we go. So what I've done, again, I've tidied this up a little bit, and I've left these values on the diagram. These are the values that are being transmitted out of that port. So when a BPDU is leaving that port, that's the value that's kind of stamped into the BPDU, representing how much it costs that switch to get back to the root bridge. So I think we're ready to go here. I mean, let's start with the easiest one. The easiest one is over here. The root path cost for the root bridge to come back to itself is a grand total of 0. 0 should always be lower than pretty much anything else. So I can guarantee you that all the ports on the root bridge will have to be designated port. There's no choice. No choice at all. It wins. 0 is less than 19. 0 is less than 19. 0 is less than 19. You get the idea. That was the easiest one. Boom. Designated, designated, designated. It wins. That's good. Now, listen, we can kind of go anywhere here. If I look at switch 2, for example, are there some easy ones that I can quickly figure out? Let me have a quick look here. Yeah, have a look at this link over here. I've got 23 here and 19 here. That's an easy one. 19 is less than 23. That has to be a designated port. So I'm going to do the easy ones first, the ones where on the segment, the values are different. And then we'll have a look at the harder ones after. So that was an easy one. How about over here? Same thing, 19 and 23. Not too complicated. 19 is less than 23. That's going to be my designated port. Are we ready for the more complicated ones? Not that complicated. Let's have a look at this segment over here. I have a problem. I have a tie, 19 and 19. I need my tie break. What's the tie break? So I have a tie on step 2. I go to step 3. Step 3 says, hey, the winner should be the one with the lowest bridge ID. Folks, is that switch 2 or switch 4? Who says switch 2? Who says switch 4? So what do we got here? 000B, BEFA, FD13. This is lower than this. That port is elected the designated port. So that was easy. Where else do we need to go? That was between switch 2 and switch 4. Let's have a look at between switch 3 and switch 4. Again, you might be wondering, Patrick, why are you doing them in this order? It doesn't matter what order you do. You just work through them. One segment at a time. It's all good. So what is this one like over here? So we're looking at 3 and 4, 19 and 19. So we have a tie. You know what I'm going to say. We go to the tie break. The tie break is the sender port sender bridge ID. Who's going to win? Is it S3 or SW4? 00B, 00B, BFA. This guy wins. Lowest MAC address, designated port. Next one is, let's do this one over here. Again, we have a tie, 19 and 19. I need to go to my tie break, looking at sender bridge ID. Got 00B FD13. Oh, 00B FD13. I got a 9. I've got a C. Pretty clear to me. This guy is going to win. Lowest bridge ID. This one is a designated port. So far, so good. After all that happens, everything else, all the other ports go to blocking. In old traditional spanning tree, Radia would have called it non-designated ports. Cisco switches call them alternate ports. You might have seen, if you do a show spanning tree on a Cisco switch, you'll see alternate ports. Now that's a lot of X's. What that means is there's no user traffic going in or out of these interfaces. They're not being used at all here. They're standby. They're waiting to do something at some point. And so what we get as an end result, there were a lot of segments here, right? A lot of cables were added, but I got bad news for you. A lot of cables aren't being used, is what's happening. So what I did is I'm just highlighting here in orange the links that are actually doing something, that are forwarding traffic. Got this one over here, and this one over here. And that one there. And that's it. So what does that mean? It means I've got a bad design. Or don't say like what my colleague Quinn said earlier. I said, oh no, it was Kareem said, I just turned off spanning tree. Don't turn off spanning tree. Don't do that. Work on your design. What's the real problem here? The real problem is that my root bridge has been badly selected. I think hopefully, right, if we think of access layer, maybe distribution layer, maybe core layer, I'd want my root bridge maybe somewhere up here instead. It depends. But at the end of the day, if I have a PC, let's just think of an example here. Let's say I've got a server connected here and a PC here. How is that PC getting to that server? It's going like this. Maybe like this. No, it's not this way. It's going to go like this, going like this, and into the server. Right? All the other links are not getting used right now. There we go, folks, ladies and gentlemen. Spanning tree in a nutshell. That makes sense. Is that okay? Yeah? Okay. Cool. So again, you're not going to get questions on the CCNA exam asking you necessarily to configure a spanning tree. You're going to be asked to kind of interpret the results of spanning tree, or they'll show you a diagram, maybe not as complicated as that one, and ask you, hey, where's the root bridge? Or which port is the root port in this? You know what I mean, right? So they'll ask you to be able to kind of articulate intelligently what happened, how spanning tree actually did its thing. I've written a couple of Cisco press books, so I reached out to them before coming here, and I asked them, can I have some free books for my attendees? And they were like, yes, fine. And I don't know if you've seen these books from Wendell. They wanted to give me actual printed books, and this is like a box set of 2 books. And I was like, can we do something else? I'm coming from Canada. I mean, I love you all, but I didn't really want to just have books in my suitcase. I needed a bit of clothes and obviously maple syrup stuff as well. So I've got 3 ebook codes for Wendell's new edition of the CCNA Cert Guide Library that I would love to give to someone who's actively getting ready to sit their CCNA, that are studying for that. If that's you, when I'm done here in a second, if you want to just kind of meet me on the side, we'll have a little draw amongst you, smaller group. I would like these books to go to someone who's actually going to use them and not just sit on a virtual shelf. Does that make sense? Just so that we get the most use out of it, if possible. So I've got 3 of these. So if you're currently studying for your CCNA and you don't already have Wendell's 2nd edition of his 2 books, come and see me and we'll do a little draw together, right? I think, let me just check something. Yeah, let me just go back here. I was told that if you look under your chair, one of you should have this thing taped under the chair. And if that's you, grab it, rip it off, wave it around. Fantastic. You get to keep that. That's all. No, I'm just kidding. You get to keep that, and you get this really nice Cisco U tumbler as well. So you need it back? You need to, oh yes, we'll take the penguin back because that's our demo penguin. I'll trade you. There you go. Thank you very much. Folks, thanks for joining me today. Appreciate it. Like I said, come and see me if you're interested in getting the CCNA books. Cheers. Thank you. Hey. Let me get rid of all my stuff. I need to make room for my colleague Kyle, who's going to come and do the next session. Sure. Yeah.